Ever wondered how Hadoop manages large data sets? Well, it's time to unravel the mystery. Imagine a colossal amount of data. Think about the scale of the entire internet. To handle such vast quantities, we need a system that's up to the task. Enter Hadoop, a framework designed especially for storing and processing big data. It's not just about the size, it's also about the speed. In our fast-paced, data-driven world, where every click, every search, every transaction counts, efficient data management is crucial. Hadoop, with its ability to process large data sets across clusters of computers, is a game changer. It's like a super efficient librarian, but instead of books, it's organizing and making sense of endless streams of data. So, ready to dive deeper into the world of Hadoop? Let's get started. Shuffling in Hadoop is an integral part of the process, but what exactly is it? Let's dive in and demystify this concept. In the grand scheme of Hadoop's data processing, shuffling is essentially an intermediary step, a pivotal point that bridges the gap between mapping and reducing. It's the process of redistributing data so that all values associated with a single key end up together. Think of it as a master organizer, grouping together similar pieces of data, ready for the next step of the operation: reduction. Now, let's bring the MapReduce model into the picture. In a Hadoop environment, data is initially processed using a map function, breaking down large chunks of data into smaller, more manageable pieces. This is where shuffling steps in. Post-mapping, the shuffle process ensures that these data pieces are effectively sorted and transferred to the reduce phase. But how does it do that? Well, it's all about grouping. Shuffling organizes the output of the map function, grouping the data based on the key values. This is a crucial step as it enables the reduce function to work efficiently, processing all values associated with a single key at once. So, shuffling isn't just a process that happens in the background, it's the linchpin that holds the MapReduce model together, ensuring a smooth transition from one phase to another. In essence, shuffling is the preparatory stage for sorting and reducing data. It's like setting the table before a feast. Now that we've understood shuffling, let's move on to the sort process in Hadoop. The sort process in Hadoop is like a well-organized librarian arranging books on the shelves in a way that makes it easier for readers to find what they need. In a similar way, sorting takes the shuffled data and arranges it in a manner that makes data reduction more efficient. After the shuffle phase, we have our data distributed across different nodes, but it's like a jumbled pile of Legos with different colors and shapes mixed together. The sort process comes into play here, arranging these Legos or data blocks in a specific order, making it easier to find specific pieces of information. In the context of Hadoop's MapReduce model, the sort process is crucial. The map function transforms the input data into a set of key value pairs. However, these pairs are not inherently organized. That's where the reduce function, backed by the sort process, steps in. It takes these key value pairs and sorts them based on the keys. This sorting makes the reduce function's job of aggregating the values for each key much more streamlined and efficient. In essence, the sort process in Hadoop is all about organization. It's about taking the shuffled data, which could be in any random order, and providing structure, making it easier to process and analyze. Sorting, therefore, is like organizing the dishes on the table so that they're easier to serve and consume. We've explored the shuffle and sort processes in Hadoop, but what's the big picture? In essence, shuffle and sort are the backbone of Hadoop's data processing mechanism. They streamline the colossal task of dealing with large data sets into manageable chunks, making data analysis much more efficient. The shuffle process is akin to a diligent librarian organizing books, or in our case data, into the right shelves, reducer tasks. It ensures that related data pieces are grouped together, ready for analysis. On the other hand, the sort process is like our meticulous sorter, arranging these grouped data pieces in a meaningful sequence. This helps in faster retrieval and efficient data processing. Together, shuffle and sort form an integral part of the Hadoop ecosystem, enabling it to tackle big data challenges. So there you have it. The shuffle and sort processes in Hadoop are fundamental to managing and processing large data sets. Remember, in the world of big data, it's not just about having the data, but managing it effectively too.